Here we have to find a differential equation of family of curve represented by x square plus y square is equal to a square, where number of arbitrary constant is 1. So our differential equations order must be 1. So we are allowed to differentiate our equation only one time. So let's differentiate with respect to x. Differentiation of x square will be 2x. Differentiation of y square will be 2y dy by dx. And differentiation of a square, which is purely constant term, will be 0. So for simplification, we can take 2 common. So let's divide our equation by 2 and we will get x plus y dy by dx is equal to 0, which is given in option A. Ta-da! In this question, we have to find differential equation of family of curve y is equal to a cos x plus b. Now here we have two different arbitrary constants a and b. So our order of differential equation will be 2. So we are allowed to differentiate our equation 2 times. Let's differentiate our equation with respect to x. So differentiation of y will be dy by dx. Your a is constant, we don't have to worry about it. And differentiation of cos x plus b will be sin x plus b. But as you can see, we can't eliminate any one of the arbitrary constant and it is a trigonometric term. So it is preferable that without any simplification, differentiate our equation with respect to x again. So we will get d square y by dx square is equal to a into differentiation of sin x plus b will be minus cos x plus b. Here, if we take negative sign outside, then we will get a cos x plus b, which is nothing but our a. So, if we substitute the value of y in our equation, we will get d square y by dx square is equal to minus of y. If we take y on the left side, we will get d square y by dx square plus y is equal to 0, which is given in option B. Ta-da! In this question, we have to find the differential equation of our equation y is equal to e raised to cx, or it may be e raised to mx. In both equations, our arbitrary constant is only 1. So our order of differential equation must be 1. So we are allowed to differentiate our equation only one time. Now, if we differentiate directly, we will get dy by dx is equal to e raised to cx into coefficient of x, which is c in this case. So as you can see, your arbitrary constant will become at more than one place, which is not so preferable because we have to eliminate our arbitrary constant. So we can say this is not the correct way. So it is preferable that before we go for the differentiation, let's take log on both sides. So we'll get log y is equal to log of e raised to cx. Now, according to the property of log, we can take this cx within the multiplication of log, and we know that the value of log e is nothing but 1. So here we'll get log y is equal to c into x. Now, it's quite looking simplified. So let's differentiate our equation with respect to x. Differentiation of log y will be 1 upon y into dy by dx. And on right hand side, we will get c as it is, differentiation of x will be 1. So we don't have to worry about it. Now, in this step, we have to eliminate our arbitrary constant. And for that, we have to use equation number 1. We can say from equation number 1, your c must be log y upon x. And substitute this value in our second equation. So we'll get 1 by y dy by dx is equal to log y by x, which can be further simplified into dy by dx is equal to y by x into log y, which is given in option C. Ta-da! In this question, you have to find differential equation of all the coaxial parabola whose equation is y square is equal to 4a into x minus b, where a and b are arbitrary constant. So we have two arbitrary constant. So our order must be 2. Now let's follow the steps. Let's say y is equal to 4a x minus b is your equation number 1. Now in second step, we have to first time differentiate. So let's differentiate our equation with respect to x. So here we'll get 2y dy by dx, and on right hand side your 4a will be as it is, differentiation of x will be 1 and differentiation of b will be 0. So here we eliminate our one arbitrary constant, which is b in this case. So before we go for the third step, let's simplify. We can cancel out this 2 and 4a will become 2a. So here we'll get y into dy by dx is equal to 2a. Let's move to the third step, in which we have to differentiate our equation with respect to x. On left hand side, we have to apply multiplication rule. In first step, your y will be as it is, and differentiation of dy by dx is d square y by dx square, plus in second step dy by dx will be as it is, and differentiation of y will be dy by dx. And on right hand side, your 2a is a purely constant term, so its differentiation will be 0. So here we'll get y into d square y by dx square plus dy by dx the whole square is equal to 0, which is given in option C. Ta-da! In this question, we have to find differential equation of all the parabolas whose axes are parallel to y-axis, which can be described by the equation of y is equal to second order polynomial, or we can say ax square plus bx plus c. Now here we have three arbitrary constants, a, b and c. That means the order of the differential equation must be 3. No problem. That means we have to differentiate our equation 3 times. So let's differentiate first time. We will get dy by dx is equal to a as it is, differentiation of x square will be 2x plus b as it is, differentiation of x will be 1 plus c is a purely constant term, so its differentiation will be 0. So here automatically one arbitrary constant is also eliminated. So let's differentiate again with respect to x. So we will get d square y by dx square is equal to a as it is, differentiation of 2x will be 2 plus b into 1 will be b, which is purely constant term. So its differentiation will also become 0 and one arbitrary constant is also eliminated. Similarly, if we differentiate third time, then we will get d cube y by dx cube is equal to 0, which is given in option A. Ta-da! In this question, we have to find the differential equation of y is equal to x plus k into e raised to minus x. Here, the only arbitrary constant is k. So, the order of our differential equation must be 1. No problem. We are allowed to differentiate only one time. So, let's differentiate our equation with respect to x. So, here we'll get dy by dx is equal to, we have to apply multiplication rule. X plus k will be as it is in first term and differentiation of e raised to minus x will be e raised to minus x into coefficient of minus x, which is minus 1, plus in second term your e raised to minus x must be as it is and differentiation of x plus k must be 1 plus 0. Now, to form a differential equation, we have to eliminate the term of k. So, we can say the x plus k into e raised to minus x is available in equation number 1. So, we can replace the entire term with y. Your minus 1 will be as it is plus e raised to minus x will also remain as it is. So, let's rearrange the term. Your dy by dx, and if we take this minus y on the left hand side, we will get plus y, and on right hand side e raised to minus x will be as it is. So this is your required differential equation, which is given in option D. Ta-da! In this question, we have to find a differential equation which is satisfied by y is equal to e raised to minus x into cos 2x. Now, as you can see, our differential equations having second order. So, we have to differentiate 2 times. So, let's say this is your equation number 1 and we are ready for differentiating our equation with respect to x. So, on left hand side, we will get dy by dx, and on right hand side, we have to apply multiplication rule. Let's say in first term, your e raised to minus x will be as it is, and differentiation of cos 2x will be minus sin 2x into 2 plus, in second term, your cos 2x must be as it is, and we have to differentiate e raised to minus x, which will be e raised to minus x into minus 1. Now, once we get dy by dx, we need to set y from equation number 1, and we know that in equation number 1, it is given that e raised to minus x into cos 2x is simply y. So, let's substitute the value of y. So, we will get minus 2 sin 2x into e raised to minus x, then minus of y. So, we get the simplified form of dy by dx. Let's say this is your second equation and we are ready to differentiate our equation with respect to x again. So, on left hand side, differentiation of dy by dx will be d square y by dx square, and we have to apply multiplication rule again. Let's say e raised to minus x will be as it is, and differentiation of minus 2 sin 2x will be minus 2 cos 2x into coefficient of x, which is 2. plus your minus 2 sin 2x will be as it is, and differentiation of e raised to minus x will be e raised to minus x into minus 1, and finally differentiation of minus y will be minus dy by dx. So we second time differentiate and we also get d square y by dx square. Now we need to set y1 from second equation. From second equation we can make minus 2 sin 2x e raised to minus x subjective. So we'll get 2 sin 2x into e raised to minus x is equal to minus dy by dx minus y. So let's substitute its value in the second term. This minus minus become plus, and we also know that e raised to minus x into cos 2x is your y from equation number 1. So our term will be simplified as d square y by dx square. Here this minus 2 and plus 2 will become minus 4. E raised to minus x cos 2x will be your y, plus this whole bracket from the second equation will become minus dy by dx and minus y, and your minus dy by dx will be remain as it is. So here we'll get minus 4y and minus y will be minus 5y, and minus dy by dx and minus dy by dx will become minus 2 times dy by dx. So here we'll get d square y by dx square. Now to get our answer, we just have to take these two terms on the left side. So we will get d square y by dx square plus 2 dy by dx plus 5y is equal to 0, which is given in option A. Ta-da! In this question, we have x is equal to a cos cube theta and y is equal to a sin cube theta, and we have to find 1 plus dy by dx the whole square, and for that we need dy by dx. Here we have parametric equation. So to get dy by dx, we have to differentiate our both equation with respect to theta. So from the equation of x, we will get dx by d theta is equal to a will as it is. To differentiate cos cube theta, we have to consider box around the cos theta. So we'll get 3 box raised to 3 minus 1, or we can say 2, into differentiation of box. Now within the box we have cos theta. So we have to multiply differentiation of cos theta, which is minus sin theta. So here we'll get dx by d theta is equal to minus 3a cos square theta into sin theta. Similarly, from the equation of y, we will get dy by d theta. Here a will be as it is, and to differentiate sin cube theta, we have to consider box around the sin theta. So we'll get box cube, and the differentiation of box cube is simply 3 box square into d by dx of box. Within the box we have sin theta, so we just have to multiply differentiation of sin theta, which is cos theta. So we will get dy by d theta is equal to 3a into sin square theta into cos theta. So we are ready to get dy by dx by taking ratio of dy by d theta upon dx by d theta. So your numerator will be 3a sin square theta cos theta, and your denominator will be minus 3a cos square theta into sin theta. Here 3a will cancel out, 1 power of sin and 1 power of cos will cancel out. So finally we will get dy by dx is equal to sin by minus cos, or we can say minus tan theta. But as you remember, we have to find 1 plus dy by dx the whole square. So let's find out 1 plus dy by dx the whole square. Your 1 will be as it is and your dy by dx is simply minus tan theta. So here we'll get 1 plus tan square theta, or we can say sec square theta, which is given in option C. Ta-da! If your y is equal to e raised to minus x into a cos x plus b sin x, then which of the following differential equations solution is your y? So let's obtain differential equation from this solution. Let's say this is your equation number 1, and if we differentiate our equation with respect to x, we will get dy by dx. On right hand side, we have to apply multiplication rule. Let's say e raised to minus x is as it is. Differentiation of the a cos x will be a minus sin x plus b cos x. In second term, your whole bracket will be as it is. Differentiation of e raised to minus x will be e raised to minus x into minus 1. So we get our dy by dx. Now we have to set the y from equation number 1. In equation number 1, it is given that e raised to minus x into a cos x plus b sin x is your y. So let's substitute the value in second term. Your first term will be as it is. In second term, the whole bracket will become your y. Due to this minus 1, we have to substitute minus over here. So we get the simplified form of dy by dx. Let's call it equation number 2. Now, let's move to the third step, in which we have to again differentiate our equation. So on left hand side, we will get d square y by dx square, and differentiation of minus y will be minus dy by dx. And to differentiate first term, we have to apply multiplication rule. So let's say in first term, your e raised to minus x is as it is, and differentiation of minus a sin x will be minus a cos x, plus differentiation of b cos x will be minus b sin x, plus in second term, your whole bracket will be as it is, and we just have to differentiate e raised to minus x. So it will be e raised to minus x into minus 1. So we get our d square y by dx square. Now, before we go further, let's simplify. Minus dy by dx will be as it is. We can take minus common from the second term, and we will get e raised to minus x, a cos x plus b sin x. And your last term will be minus of minus a sin x plus b cos x into e raised to minus x. Now, we have to use equation number 2. From equation number 2, we can say your middle term, which is e raised to minus x minus a sin x plus b cos x, is equal to dy by dx plus y. So let's simplify. Your minus dy by dx will be as it is, minus this e raised to minus x, a cos x plus b sin x is simply y from equation number 1. And from second equation, we can say minus a sin x plus b cos x into e raised to minus x is simply dy by dx plus y. So here we'll get d square y by dx square is equal to minus dy by dx minus y and again minus dy by dx and minus y. So here we'll get d square y by dx square plus 2 times dy by dx plus 2 times y is equal to 0 is your required differential equation, which is given in option C. Ta-da! We have to obtain the differential equation of y is equal to sec tan inverse x. All the differential equation having first order. So we are allowed to differentiate only one time. So let's differentiate our equation with respect to x. We will get dy by dx is equal to differentiation of sec box. And the differentiation of sec box is simply sec box into tan box into d by dx of box. Within the box we have tan inverse x. So we just have to multiply differentiation of tan inverse x, which is 1 upon 1 plus x square. Now if we move this 1 plus x square on the left side, we will get 1 plus x square into dy by dx is equal to sec tan inverse x, which is your y from equation number 1. So let's write down this sec tan inverse x as your y. And tan and tan inverse are inverse function of each other. So tan inverse x will be your x. So we get our required differential equation 1 plus x square into dy by dx is equal to y into x, which is given in option C. Ta-da! Here we have to find a differential equation of all the circles which is passing through the origin and having center on the x-axis. Or this question is also asked in the form of find a differential equation of family of circle touching the y-axis at the origin. Both questions represent the same family of curve. Now, before we go for the equation, let's consider our xy axis. Now, if you have to draw a circle having center on the x-axis and passing from the center, or we can say touch the y-axis at the origin, will have the radius of r. Then its center must be r, 0. Now we know the general formula of circle, which is x minus a the whole square plus y minus b the whole square is equal to r square, where its center is a, b and radius is r. Now in our question, the center is r, 0 and radius is r. So we can say the family of our curve will be represented by x minus r the whole square plus y minus 0 the whole square is equal to r square. Now we can simplify this as x square minus 2xr plus r square plus y square is equal to r square. Now here your r square can be cancelled out and we will get x square plus y square is equal to 2xr. So finally we get the simplest form of equation of our family of curve, in which the arbitrary constant is r. So we can say the order of our differential equation must be 1. So we are allowed to differentiate only one time. Let's say this is your equation number 1 and let's differentiate our equation with respect to x. So differentiation of x square will be 2x plus differentiation of y square will be 2y into differentiation of y, or we can say y1 is equal to, on right hand side, 2 and r are the constant. We just have to differentiate our x, which will be 1. So we get our second equation. Now we just have to eliminate this arbitrary constant r, and for that we will use our first equation. From first equation we can say 2r is equal to x square plus y square upon x. Substitute this value on the right hand side. We will get x square plus y square upon x is equal to 2x plus 2y1. Let's move this x on the left hand side. So 2x multiplied with x will give us 2x square, and 2x multiplied with 2y1 will give us 2y1 into x is equal to x square plus y square. Now if we move this 2x square on the right hand side, we will get minus 2x square. So finally we will get y1 is equal to y square minus x square upon 2y, which is your required differential equation given in option D. Ta-da! Here you have to find a differential equation of family of circle which is passing from a, 0 and minus a, 0. First of all, we have to use the general equation of circle, which is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Now, here we have three different arbitrary constants, g, f and c, but number of arbitrary constants can be removed by using the condition which is given in the question. Now, our circle is passing from a, 0. So here your x coordinate is a and y coordinate is 0. So our equation will become a square plus 0 square plus 2 times g of a plus 2 times f into 0 plus c is equal to 0. So here we'll get a square plus 2ga plus c is equal to 0. Let's say this is your equation number 1. Now, it is also passing from minus a, 0. So, it is also satisfied our equation. So, our equation will become a square plus 0 square minus 2ga plus 0 plus c is equal to 0. So, here we'll get a square minus 2ga plus c is equal to 0. Let's say this is your equation number 2. Now, if we try to solve by taking difference between these two equations, we will get a square minus a square will give us 0. 2ga plus 2ga will give us 4ga, and c minus c will become 0. So, here 4 and a are not 0. So, we can say your g must be 0. And if we substitute this value in any one of the equation, we will get a square plus c equal to 0, which will give us c is equal to minus a square. So we get the value of g and c. So we can say our general equation of circle will be simplified as x square plus y square plus 0 plus 2fy, and instead of c we have to substitute minus a square is equal to 0. And we only have one arbitrary constant. So now the order of our differential equation will be 1. So let's say this is your equation number 1 and we are ready to differentiate our equation with respect to x. So we can say differentiation of x square will be 2x, differentiation of y square will be 2y into differentiation of y, let's say y1, plus differentiation of 2fy, or we can say your 2f are the constant, we just have to differentiate y, which will become y1, and differentiation of a square will be 0. On right hand side we already have 0. So now we just have to eliminate our arbitrary constant f. So we are going to use our equation number 1. From equation number 1 we can say your 2f is simply a square minus x square minus y square upon y. Now let's substitute this value in our term. So we will get 2x plus 2y1 plus, instead of 2f we have to substitute a square minus x square minus y square whole divided by y into y1 is equal to 0. Now in further simplification we can say we have to multiply this y with 2x will give us 2xy plus y multiply with the second term will give us 2y square into y1 plus this y1 will multiply with a square will give us a square y1 into x square will give us minus x square y1, and finally minus y square y1 is equal to 0. Now here your first term will be as it is, and this 2y square y1 and minus y square y1 will become plus y square y1, and if we take y1 common from the rest of the terms we will get minus x square plus a square into y1 is equal to 0, which can be considered as your required differential equation given in the option C. Ta-da! Here we have to find differential equation of y is equal to a cos alpha x plus b sin alpha x, and a and b are arbitrary constants. Now sometimes they take alpha equal to 1 and our equation will become a cos x plus b sin x. Then we have to follow the same steps. Here the number of arbitrary constant is 2, so we can say the order of differential equation will also 2. So we have to differentiate our equation 2 times. Okay, now let's say this is your equation number 1 and we differentiate our equation with respect to x. So your y will become y1 and this a will be as it is, differentiation of cos alpha x will be minus sin alpha x into coefficient of x which is alpha, plus b will be as it is, differentiation of sin alpha x will be cos alpha x into coefficient of x which is again alpha. So here we get y1. Now traditionally we have to eliminate any one arbitrary constant, but here we have purely trigonometric terms. So instead of eliminating a or b, let's differentiate again with respect to x. So your y1 will become y2, and in first term minus a alpha will be as it is, and we just have to differentiate this sin alpha x. So it will be cos alpha x into alpha, plus in second term b and alpha will be as it is, and differentiation of cos alpha x will be minus sine alpha x into alpha. Now, as you can see, we can take minus alpha square common from these two terms, and we will get a cos alpha x plus b sin alpha x, which is actually your y from first equation. So here we'll get y2 is equal to minus alpha square into y, or we can say d square y by dx square plus alpha square y equal to 0 is your required differential equation, which is given in option B. Ta-da! In this question, we have to find a differential equation which satisfies y is equal to a e raised to mx plus b e raised to minus mx, where a and b are arbitrary constants. So here, number of arbitrary constant is 2. So your order must be 2. So let's say this is your equation number 1. And we are ready to move in the second step, in which we have to differentiate our equation with respect to x. So we will get y1 is equal to a as it is, differentiation of e raised to mx will be e raised to mx into m, plus b as it is, differentiation of e raised to minus mx will be e raised to minus mx into coefficient of x, which is minus m. So here we get y1 is equal to am e raised to mx and minus bm e raised to minus mx. Now, traditionally, we have to eliminate any one arbitrary constant, and let's say we can eliminate b from equation number 1. But if we don't eliminate this term and continue our journey of differentiating, then we will get differentiation of y1, which is y2. Then in first term, am will be as it is, differentiation of e raised to mx will be e raised to mx into m. And in second term, bm will be as it is, and differentiation of e raised to minus mx will be e raised to minus mx into minus m. Now here, as you can see, this minus minus become plus, and we can take m square common. So we will get a into e raised to mx plus b into e raised to minus mx is equal to y2. Now as you can see from equation number 1, we can say instead of this a e raised to mx and plus b e raised to mx, we can write down simply y. So this y2 is equal to m square into y, or we can say d square y by dx square minus m square into y is equal to 0 is your required differential equation, which is given in option C. Ta-da! Now here we have to find a differential equation of family of curves y square is equal to 4a into x plus a. Now here your arbitrary constant is only a. So we can say order of differential equation must be 1. So we are allowed to differentiate only one time. Let's say this is your equation number 1, and if we differentiate with respect to x, we will get 2y into y1 is equal to your 4a will be as it is, differentiation of x will be 1 and differentiation of a will be 0. So we get our y1. Now we have to eliminate this 4a. Now instead of getting the value of 4a from equation number 1, let's say from equation number 2 we will get 4a is equal to 2y into y1, and substitute this value of a in equation number 1. So we will get y square is equal to instead of this 4a, we have to substitute 2y into y1 and x plus, instead of this a, we have to substitute y1 upon 2. If we open the bracket, 2y1 into x will give us 2y into x into y1 plus 2y1 multiplied with y1 by 2 will give us y square into y1 square is equal to y square. Now here we can take y common. So we will get y is equal to 2x into y1 plus y into y1 square. Or we can move this y on the right side and we will get minus y is equal to 0. So if we rearrange the term, we will get 2x into y1, or we can say dy by dx, plus y into y1 the whole square, or we can say dy by dx the whole square, minus y is equal to 0 is your required differential equation, which is option D. Ta-da! Here you have to find a differential equation of system of all circle of radius r in xy plane. Here the given data is your radius, so it will not consider in arbitrary constant. Now the general equation of circle is x minus a the whole square plus y minus b the whole square is equal to r square, where your a and b are the arbitrary constant. So we can say the order of our differential equation will be 2. Now let's say this is your first equation. Now we are ready for the second equation. Let's differentiate our equation with respect to x. So differentiation of x minus a the whole square, or we can say box square, will be 2 box, or we can say 2 times x minus a into differentiation of x minus a will be 1. Similarly, differentiation of y minus b the whole square will be 2 times y minus b into differentiation of y and b. So differentiation of y is nothing but y1 is equal to differentiation of r square will be 0, because your r is a purely constant term. So here we get our second equation. Now we have to eliminate any one arbitrary constant. Let's get the value of x minus a from the equation of 2, which will be minus y minus b into y1, and substitute this value in first term of equation number 1. So here we'll get y minus b the whole square into y1 square plus y minus b the whole square, and your r square will be as it is. In further simplification, we can take y minus b the whole square common. So we will get y1 square plus 1 is equal to r square. Let's say this is your third equation and simplest form of equation of y1. Now we are ready to move in the third equation. Let's differentiate again. On left hand side, we have to apply multiplication rule. Let's say y minus b the whole square will be as it is, and we have to differentiate y1 square plus 1. Now differentiation of y1 square will be 2y1 into differentiation of y1, which will be y2, plus differentiation of 1 will be 0, plus in second term your y1 square plus 1 will be as it is, and we have to differentiate your y minus b the whole square, which will be 2 times y minus b into differentiation of y, which is y1, is equal to differentiation of r square, which is purely constant term, will be 0. Now let's further simplify. Your first term will be remain as it is on the left hand side, and let's move our second term on the right hand side, so it will become negative. Now here your 2 and y1 can be cancelled out, and 1 power of y minus b will also cancel out because your y is not equal to b. So here we'll get y minus b into y2, and on right hand side the only remaining term is minus of 1 plus y1 square. Now if we square both sides, we will get the whole square of 1 plus y1 square. Now to get the final form of differential equation, we have to eliminate our last arbitrary constant, which is y minus b, and for that we are going to use our previous equation, which is equation number 3. From equation number 3 we can say y minus b the whole square is equal to r square upon 1 plus y1 square. Now let's substitute this value, so we will get r square upon 1 plus y1 square into your y2 square is equal to 1 plus y1 square the whole square. Now if we move our 1 plus y1 square on the left hand side, we will get r square into y2 square, or we can say d square y by dx square the whole square is equal to 1 plus y1 square, or we can say whole square of dy by dx whole raised to 3. So tada! We can say this is your required differential equation, which is given in option C. Tada! In this question, we have to find a differential equation of straight line whose slope is equal to y-intercept. Now, the general equation of straight line is y is equal to mx plus c, where your m is slope and c is y-intercept. Now, it is given that your slope is equal to y-intercept. So, our required equation of family will be y is equal to, instead of m, we just have to place c into x plus c, or we can say your y will be equal to c into x plus 1. Let's say this is your equation number 1. Now here the only arbitrary constant is c, so the order of differential equation must be 1. Okay, so let's differentiate our equation with respect to x. So your y will become y1 is equal to c will be as it is, differentiation of x will be 1 and differentiation of 1 will be 0. So here we get our equation number 2. Now to eliminate c, let's say substitute the value of c in equation number 1. So we will get y is equal to y1 into x plus 1, or we can say x plus 1 into y1, which is dy by dx minus y is equal to 0, is your required differential equation, which is given in option A. Tada! Here it is given that your y is simply a by x plus bx square, and we have to find out x square into d square y by dx square. So before we go for the differentiation, let's take a LCM of x. So we will get x into y is equal to a plus b into x cube. So we are ready to differentiate our equation with respect to x. So on left hand side we have to apply multiplication rule. your x will be as it is, differentiation of y will be y1 plus your y will be as it is, differentiation of x will be 1. On right hand side, differentiation of a, which is purely constant term, will be 0, and in second term b will be as it is, differentiation of x cube will be 3x square. So here we eliminate one arbitrary constant. So let's say this is your equation number 2, and we are ready to move in the third equation, in which we have to again differentiate with respect to x. Now in first term we have to apply multiplication rule. Your x will be as it is, differentiation of y1 will be y2 plus y1 will be as it is, differentiation of x will be 1 plus differentiation of y will become y1. Now on right hand side, your b will be as it is, and differentiation of 3x square will be simply 6x. Now as we know, we have to eliminate our arbitrary constant b, and for that we have to use our second equation. From second equation we can say your b is simply x into y1 plus y whole divided by 3x square. So if we substitute the value of b on the right hand side, we will get 6x into x y1 plus y upon 3x square. Here we'll get 3 2s are 6, and 1 power of x will cancel out. And on left hand side, we will get x into y2 plus y1 will become 2y1. Now, in further simplification, we have to multiply our remaining x on the left side. So we will get x square into y2 plus 2y1 into x is equal to, now on right hand side we have to multiply 2 with xy1, we will get 2xy1, and 2 multiply with y will give us 2y. Now here 2xy1 will cancel out, and we will get x square into y2, or we can say d square y by dx square is equal to 2y, which is given in option A. Ta-da! In this question, we have a family of curve y is equal to e raised to a sin x, where a is your arbitrary constant and we have to find the differential equation. Now, here we have only one arbitrary constant, so the order of differential equation must be 1. Before we go for differentiation, let's simplify by taking log on both sides. So on right hand side we can say this a sin x, which is in power of e, will go within the multiplication of log, which will give us a sin x into log e, and we don't have to worry about this e because its value is 1. So finally we will get log y is equal to a sin x. Let's say this is your equation number 1. Now we are ready to differentiate our equation with respect to x. So differentiation of log y will be 1 upon y into differentiation of y, which will be y1. On right hand side, a is constant, we don't have to worry about it. Differentiate sin x, which will be cos x. But to get the final form of differential equation, we have to eliminate our arbitrary constant from equation number 1. So we can say your a is nothing but your log y upon sin x. Substitute the value of a and we will get log y upon sin x into cos x. Your left hand side will be as it is. Now let's rearrange the term. sin x upon cos x into y1 will be equal to y into log y, or we can say y log y is equal to this sin x upon cos x can be rewritten as tan x into y1, or we can say dy by dx. So here we get our required differential equation, which is given in option B. Ta-da!